Welcome to the solutions and notes for day 10 of our GCSE 5 a day. Now, question 1 is something that comes up in all sorts of areas of life and in all sorts of jobs, where we're reading from scales on all sorts of measuring instruments or containers. And the scale has some numbers on it, but it has lots of marks on it where there aren't numbers, and we need to do some maths here to work out what's going on. And we've got part of a scale here from a jug, a measuring jug for liquids. And so we've got exactly what I say. We've got some numbers at the bottom here. We know that we're going from 0 to 100. It's ml. So we are working in millilitres. We don't need to know that for this question, but it's always worth noting. We're asked, what on earth is this here? Well, we obviously can't count 0, 1, 2, 3, because the next number would be 4, but it's 100, so that can't be right. And what we need to think about here is that we have split this gap from 0 to 100 into 4 equal spaces. Now, that to me looks very like the picture that we draw when we're dealing with fractions. And so if this whole distance here represents 100, and on our diagram we see it does from 0 to 100, then each of these spaces here must be 100 divided by 4, which equals 25. So what we find is that we're actually going up in 25s. 0, 25, 50, 75, 100. So 0, 25, 50, 75, 100. So our answer there, and I think by the time we've got to day 10, we've remembered that we need to include the units, millilitres, in our answers. So there we go. And if you want to do a sensory nugget with more of these, and these are really important problems, not just for your maths exam, but also in day-to-day life and in work, then try that nugget there, 36.01. Okay, question 2. Now, this is an exercise in substitution, where we have an algebraic expression here, 3a plus 2c, and we are told what these values are. So we simply need to replace the a and the c into our expression. Now, 3a means 3 times, and we're told that a is 4, so 3 times 4 plus 2 times negative 2. So our BIDMAS rules tell us to do the multiplication here before the adding. We do our division and multiplication before our adding and subtracting. So we're going to do 3 times 4, which is 12. We've got 2 times negative 2, so that's negative 4. So we end up with 4 plus negative 4, which equals 8, plus our negative number is the same as 12 minus 4, so that equals 8. So there's our answer there, 8. Plenty more examples of substitution that you can try at 17.14. But I think if you've made a mistake with the negatives, then please go and have a look at this nugget here. I say this to you all the time, that you can do this maths correctly if these numbers are positive, and then suddenly a few mistakes keep kicking in when we have negatives. So please, if that's the case, then don't worry about going and do the substitution nugget. Then go away and do the negative number nugget 2.05, because that's going to apply in all sorts of areas of your maths. Okay, question 3. Gosh, it's day 10, and this is the first time that we've had a factorise question. Now we've got two instructions that come together in our algebra. One is to factorize and one is to expand. And these are reverse processes of one another. Okay, so think about factorize. This is about breaking something into its factors. So the factors of 6 are 2 times 3, 1 times 6, because these are what multiply together to create that number. Now, we've got an expression here, 3y plus 15. And what we're looking for is there any common factor that goes into both of these? Well, let's look at the two elements of my 3y. This is 3 times y. So I need to be looking for, is there a y inside here? No, there isn't. Is there a 3 in here? Ah, yes. 15 is 3 times 5, isn't it? So we have this common factor of 3. So we can put brackets in here. Now there's an invisible multiplication sign in there. Y plus 5. If you came across a question that said expand 3y plus 15, then we'd be asked to apply this 3 to everything inside the bracket. So we do it here, 3y plus 15. So it's very easy to check these questions by doing the reverse process and see if you get back to where you started. But our answer here is 3y plus 5. Okay, so if you want to go and do a good nugget like this with some more examples like this, practice nugget 18.08. If you struggle a bit with that, maybe go back a step and try nugget 18.07. If you want to have a look at some expanding, then the nugget to look for there is 18.01. But there are always a few marks for this in the exams, so these are good little nuggets and good skills to practice. But make sure that we know what these two command words mean. Okay, question 4. We've got a nice little logic puzzle here about this number that Max has thought of. And this is an ideal question for using one of the little tools that sometimes confuse students. And maybe this is this strange word, function machines. So what we're going to do, we're just going to lay this out as a little diagram of operations. So Max has thought of his number. I'm going to call it M. And the next thing that he does is that he squares this number. Then the next thing that he does is that he adds 4. And out at the end of this process comes the answer 53. Well, what we've got to do is go, well, look, if the answer was 53, what on earth was this number? Well, the way we're going to do this is to actually just put this process into reverse. And we're going to start with 53. And the way we look at this is we're going to do inverse operations. And the inverse of adding 4, the thing that takes us back to where we started, is to subtract 4. So if we take 53, 53 take away 4 is 49. So our number is now 49. Now, what's the inverse operation of squaring? Now that is our cheeky little square root. So what is the square root of 49? This is a test of whether we can remember our square numbers. Well, that is 7, because 7 times 7 makes 49. So there we have our answer as 7. If you want to practice similar nuggets like that, then the place to go on century is 17.12. Okay. Question 5. What we have here is called a two-way table. But it's called a two-way table because we've got one set of properties, languages, going along this top axis, and we've got another set of properties, in this instance gender, going down this other axis. Okay, so that's why it's called a two-way table. It's kind of a two-dimensional table, a 2D table. And we're being asked about probabilities. Now, probability is best thought of as a fraction. So what is the probability of the student? Okay, so of the students, so that's out of all the students, and we want the ones studying German. Okay, so what we're after here is how many are studying German? Well, that's these two here, isn't it? Okay, so that's 6 and 8. So that's 14 in total. So we've got 14 out of all the students. Well, how many have we got altogether? As well as these 14, we've got this group here. So these add up to 26. So in total, 26 and 14, we have 40. So this is 14 out of 40. That is our probability. Always good if we've got a fraction to simplify it. What can we do to the top and the bottom? Okay, we can divide by 2. So another possible answer would be 7 out of 20. And some of you may convert that into a decimal. So if you convert it into a decimal, that'll look like 0.35, which is okay. Some of you might say, well, actually, I'm going to convert that into a percentage. Now, yes, but not really. Can we make sure that if we're doing probabilities, can we just try and stick to fractions or decimals, please? Okay. So there we have a range of answers, 14 out of 40, 7 out of 20, 0.35, all of which are equal to one another. And if you want to go and practice some more probability questions from two-way tables, then the nugget to go to on century is 46.05. I hope you're enjoying your 5 a day, and I hope you enjoyed the questions today. If you're having any problems at all, please ask your maths teacher.